solving systems of equations. More precisely, it's going to be solving systems of linear equations. So we're talking about lines. That's the whole unit's going to be about. It's kind of a review of what you did in Algebra 1. We're going to solve by graphing. The solution to the system is the intersection, which basically is a collection of points that are shared by two or more geometric shapes. And like I said, geometric shapes we'll be talking about are going to be the two lines. So if they intersect at one point, I'm going to go through a graph a line, graph another line, see where they meet, and that x and y together would be the equation or the solution to that system. Infinite many solutions would be almost like here. I graphed the line, went back, and I graphed the second line, and kind of had deja vu and happened to graph the exact same line twice. Okay, no solutions would be that there is no intersection, and what that would look like is a couple of parallel lines. Remember, parallel lines have the same slope. Alright, so just checking to see if ordered pairs are solutions to a system. In a system, we've got two equations. In each equation, I guess not each equation, but in the equations, you have an x and a y. The idea is that if you have two unknowns, you need two equations in order to solve this. So I'm going to check point 1, 4. So in A, I'm going to put in an x and a y. In the top one, I put 1 minus 3 times 4. So that's supposed to work out to be -5. Well, 1 minus 12 is -11. That's definitely not -5. So 1 comma 4 is not the solution to the system. Okay, so point B, so x I'll put in -5, and y I'm going to put in 0. So that will cancel out to 0. So yeah, -5 is equal to -5. But that's not enough. I got to make sure that not only it works in the top equation, but it works in the bottom one. So I'm going to put -2 times -5 plus 3 times 0, and that's going to work out to be 10. Okay, again, that's going to work out to be 0, and -2 times -5 is 10. 10 is equal to 10. It works into that one. So this is the solution to our system. All right, so graphing. I'm going to find out where they intersect. Now, you could put these into slope-intercept form. I'll do one here in purple. But since it's in standard form, I'm going to find the x-intercept, and I'm going to find the y-intercept. So the x-intercept is putting 0 in for y. So it's basically like taking that out and solving 2x equals -8. Divide by 2, and I get x is -4. Okay, if I want to find the y-intercept, now it's 0 comma something, so the x goes away. Divide by -2, and I get y is +4. So on the x-axis, I'll put one ordered pair at -4. And on the y-axis, I'll put another one at +4. Connect those two lines, and there's the graph of one line. Okay, here I'll do the second one here in blue. Same thing, it's in standard form. So to find the x-intercept, 0 in for y, so that goes away. So 2x equals 4, divide by 2, and I get 2. Okay. Find the y-intercept, put 0 in for x, so now the x goes away, divide by 2 and get 2. So when plotting this on both x-axis and put a 2, and on the y-axis I'll put 2, and I'm going to see where they meet. Okay, and it looks like it's going to be right around -2 and about, I'd say -2 and maybe like a 3. Okay, now these are going to work out to be whole numbers. So like I didn't draw my graph too terribly accurate. But yeah, maybe be a little bit more precise in your graphing. But you get the idea. Okay, same idea. This time I'm going to try slope-intercept form. So I'm going to take this one, and I'm going to get 4y by itself. So I'll subtract the 2x. Divide by 4. I get y is equal to 3 minus 1/2 x. So I'll start off at 3, 1, 2, and 3. And go down 1 over 2. Down 1 over 2. Down 1 over 2. Okay. Or I could go up 1 and to the left 2. Up 1 to the left 2. That should be good enough to get that line. Okay. In red, I'll take care of this one. So I'll get 2y is equal to 6 minus x. Divide by 2. And I get y equals 3 minus, and there's a 1 right here, so 1/2 x. So I'll put it at 3, and I'm going to go down 1 over 2, down 1 over 2, and I'm going to have the exact same line drawn twice. So what this is there is infinitely many solutions. So as long as you pick an x and a y on that line, you're going to have a solution. So here we go. I'll do the same thing. I'm going to get y by itself. Well, actually, better yet, I'll just say x equals 5. And if I cancel that out, divide by -1, y is -5. Okay. There's one line. Okay. Slope-intercept form. So -2y equals 14 minus 2x. Divide by -2, and y is -7 plus x. So I'm going to go down to -7, and I'm going to go up 1 over 1, up 1 over 1, and there I have right there. Hey, they're parallel to each other, so that means there is no solution. There is no point at which they're going to cross, so no solution. Okay, so you plan to work 200 hours this summer mowing lawns and babysitting. So you need to make a total of $1,300. Babysitting pays $6 per hour, and lawn pays 8 hours per hour. How many hours should I work each job? So I like to identify the unknowns. So in other words, write down that X stands for and Y stands for. So X is the number of hours. Let's go with the first job I see, mowing lawns. Y is equal to the number of hours babysitting. Okay, so now there are 1, 2 unknowns. That means I need 1, 2 equations. So I'm going to write one equation involving the 200 hours. I know that the number of hours I work at the mowing plus the number of hours working at babysitting has to add up to be 200. Okay? The total amount of money I need to make is 1,300, but what I need to do is I need to take and change this X, which is number of hours, and turn it into dollars. So I'm going to take the rate that I get paid per hour babysitting and multiply it by X. So that's $6 times X plus, what is it, $8 times Y will add up to be the total number of hours. Now, graphing 200 and graphing 1,300 on your graph, probably not the most ideal situation, but I'll tell you this, there are better ways to solve than by graphing. What I want you to get into the swing of things is writing these two equations. That's really going to help you out in the end.